just get started. Is that working, by the way? Everybody can hear me? Okay. So, I'm Matthias Clasen. I work in the Red Hat desktop team. I'm actually a manager there.
Can you wait for another minute or two, please? I mean, we are having a bit of technical trouble with YouTube.
Sure.
Thank you. Okay, we can go now.
All right. I'll start again. So, my name is Matthias Clasen. I work in the desktop team at Red Hat. I'm actually a manager there, so all you hear today is just hearsay from my perspective. The people who do the actual work for me. And in particular, if you're really interested in in-depth technical updates on Wayland, I highly recommend looking at the summary that appeared in LWN last week of Jasper Samtier's update that he gave last week in Guadec, where he talked about his work on Wayland porting of GNOME, and there was really a lot of good information there. So you should really read that if you want to get in-depth information. I'll just stick to the more high-level overview here today. But let's see how far we get. So my topic was, where's Wayland? And one answer is, obviously, it's close to where I live. So you can see it down here, that's Wayland. Boston is off to the east, and I actually live a little up there. You can see Acton, that's where I live. And if you go a little further up, you get to Westport, where the Red Hat office, the Boston office, so as we call it, is located. And if you look around here a little to the east of Wayland, you can also see Weston, which is another well-known name in this space. So that's one answer to the question in my topic, and we can almost leave it at that. But of course, Wayland is also in Fedora 21. So you can, if you're running Fedora 21 or Rawhide even, you can just on the login screen select a Wayland session and try things that way. And it even kind of works. I do that every now and then. I don't run it every day, but whenever I try it, I can get things done. And every week, a few more things start working, so progress is being made, and you can follow along if you want to try it out. But maybe it's actually worthwhile stepping back a little bit and talk about what Wayland actually is. And I'll spend the first half of my talk or so giving a little overview over the Wayland ecosystem and why we would be interested in doing that kind of thing. So on a basic level, Wayland is really just a protocol definition. It's like a specification of a client-server protocol, and the protocol defines whether that application is a Wayland compositor, if it speaks the server side of that protocol, or whether it's a client, if it speaks the client side of that protocol. And the communication between the two sides works over a socket, so that is all very much as you would expect it, and as you also know it from X, so there's not much different here yet. And clients obviously normally don't implement the protocol manually themselves. They use toolkits like Qt and GTK, which support Wayland nowadays. And the toolkits in turn don't really implement the Wayland protocol themselves either. They use support libraries for this purpose, so that's the next point on this list. Wayland provides a number of support libraries that make it easier to implement the Wayland protocol. And then further down the list, the Wayland project also provides a reference implementation of the server side. Like there's a compositor called Weston, which you saw earlier on the map. And I say here a reference compositor, but it's actually used in some product environments nowadays. So they actually build something that's good enough to be used in a lot of embedded and IVI situations. And then there's some other components, like I mentioned here, X-Wayland, which is a rootless nested X server. So it's basically like XNest, only that it runs not underneath X, but underneath Wayland, which is something that's really necessary to support transitioning an entire distribution over to a new protocol, because you cannot really expect all the applications to make the switch at the same time. So if you still want to run an X application on a Wayland desktop, you'll transparently get this X server started, and things will appear pretty seamless, hopefully. But yeah, next part of this talk is I want to talk a little bit about the principles that are behind the Wayland protocol design, just so you get an impression of why you might want to move off X and what the goals were here in designing this new protocol. So one thing that Christian Höchberg always likes to say, who is the original Wayland architect, every frame is perfect. And with frame here we mean really just the refresh of a screen content that gets drawn every 60 milliseconds or so. So each of those frames should be perfect in the sense that there's no artifacts and no half-drawn content on the screen. And this is just a principle. It doesn't mean that if you're running a Wayland desktop, every frame is actually perfect in practice. What's meant here is that the protocol is designed with this in mind, and in theory, at least, the protocol does not put up obstacles to achieving this goal. And to explain that in a little more detail, I put down 2 more bullet points here. Atomic commits, that really means that we can also say double buffering. So if the compositor wants to render a frame, it needs, of course, the new content for the surface that it wants to draw, but it needs a bunch of other things like the surface, but also for all the ancillary information that you might need to render it. And that, of course, is driven by this principle that we want the compositor to always have all the information it needs to perfectly render the next frame. It never be a situation where it maybe only has half the information, or half the information is new and half the information is old, and it cannot really render a good frame. Yeah, and then another principle, I'll talk about that a bit more in a bit, is the idea that we want to avoid synchronization when we can, just so we don't miss frames and things can flow nicely. Yeah, next principle, I've made that up myself. I'm not sure if that's actually something that has been put forward as a Wayland principle, but everything is client-side, more or less. A few prominent examples for that are fonts, are all handled on the client side. That's nothing new. X has been doing this for like the last decade or more. Any server-side fonts are just relics of the past, and there were a few attempts to implement more modern server-side font frameworks like STSF, but all of those have fallen by the wayside, and using font config on the client side is what you're doing under X anyway, so Wayland just continues that. The same goes for rendering. No X application is using the X protocol to render lines or circles or polygons. That's all done client side, and you just send a full buffer to the X server. And same goes for Wayland. Nested windows or sub-windows, that may be a bit more technical, people might not know about that, but modern toolkits like GTK actually really only use X windows for their top level, like the actual window, and then X allows you to have like small sub-windows like for your entries or for your what other controls you put inside your window. And toolkits don't really use that anymore under X either. Like GTK has for like the last 3, 4, or 5 years had something called client-side windows, where essentially we generate this sub-window hierarchy on the client side and manage it ourselves. And we really only bother the windowing system for top levels. And Wayland takes that one step further. It doesn't, like X allows you to create sub-windows, but nobody does it. And in Wayland, you can't really create sub-windows at all. It does have a concept of subsurface, but that's a little different. So I'll skip that here. The last point is maybe the newest one, and probably still somewhat controversial. Under X, traditionally the window decorations, like the colored frame around your top-level window, gets drawn by the window manager, so not exactly server-side from the windowing system perspective, but it's not drawn by the client. And Wayland kind of encourages applications to do that themselves as well. And GTK has been supporting that like for a year now, since last year. And yeah, that's still somewhat controversial. There's strong opinions on this, and some people just really don't like it.
The K-Wind developers, they said that window decorations will remain server-side on K-Wind doing even on Wayland?
Yeah, you can do that on the Wayland as well. On the GNOME side, we just don't want to, basically. The protocol is neutral on that matter, more or less. We want to do the decorations client side because it has some advantages, like on the last slide I mentioned, that we want to avoid synchronization where we can. And if only one application ever draws the content and provides the content for the whole surface, then you don't have to synchronize between the application which draws the actual window content and the window manager which draws the frame around it. And that's an extra synchronization which we can avoid by doing it this way. And also it gives the design a lot more freedom to actually make use of the title space, which is something our designers appreciate. So, as I said, that's still somewhat controversial, but nevertheless, it's there. This is a little more substantial, maybe not so cosmetic. Clients are isolated, which means that if you're writing a Wayland client, there's no way for you to find out global coordinates. You cannot actually know where your window is placed there's no concept of a root window, so it doesn't even make sense to ask the question, where's my window positioned on the root window relative to other applications? You just don't get that information. And then there's no grabs, really, which is another X concept that kind of allows you to interfere with other applications by stealing their input. And yeah, X was wide open in all these aspects. Every client can basically get everything on his own windows, on other applications' windows. It can get events meant for other applications and all that. So, and that's of course useful in some cases. There's very important classes of applications where you need that kind of global access. For instance, if you want to take a screenshot of the whole screen, that's not just your window, so you kind of intentionally want to get the content of other windows. And the valid answer for that is that there should be privileged clients for these special purposes, and they can talk to the compositor with a different interface or different API, and then get the special access they need. So screenshots and screencast is one example of that. Other examples are maybe accessibility, where you really want to have a way to find out where the mouse pointer is right now, over which application is it currently hovering, that sort of thing. And input methods, where you have a dedicated client like the IPAS server, which really wants to have a special access to all the input that goes by in the compositor and be able to pre-process it in some way. So that's where Wayland would suggest to use privileged clients for these special purposes. And yeah, why is this interesting? It's basically, you can summarize this slide by saying Wayland makes it possible to sandbox applications from the display server perspective, whereas under X it's really basically impossible to do that. There have been some attempts to add the necessary security extensions to X to do it, but it's really hard to do this after the fact and retrofit it into an existing system. So all that has basically gotten over, and if you want to do sandboxing with X, the basic answer is, well, you have to use XNest and really run a separate X server for each application. Right, so more principles. Compositing at the core, I made that up myself as well. In X, compositing was added as an afterthought to a non-composited windowing system. And people quickly recognized that having the window manager, which manages the position of all the windows and draws frames around them, and the compositing manager being separate processes, does not really make that much sense. It's kind of hard to keep them in sync, and you add a lot of overhead and extra protocol for communicating between the two. So under X, compositors nowadays are all compositing window managers, so those two roles have effectively merged. And what Wayland is doing here is basically taking this one step further and saying it does not really make much sense either to have the compositor and the display server be two separate instances, or the window manager and the display server be two separate instances. There's a good chunk of the X protocol that is really just dedicated to enabling communicating between the window manager and the display server about intercepting client requests and forwarding them to the window manager so it can reject them or modify them. And all this complication goes away if you just say, we'll put it in one process, then these two things can like talk to each other without needing a public protocol for that. And they can share the state inside one process. So that makes many things a lot easier. And in particular, it means that you can actually make compositing the basis of your display system, and everything under Wayland is always composited. Right, so this gets towards the end of the principles section, so you can see I kind of ran out of ideas here. This is not very impressive as a principle. But the Wayland protocol is split into multiple interfaces, and there's a few examples here. There's one interface, WLC, which describes what under X you would call a display. Basically, you have an output, you have some input, like a keyboard and a mouse, possibly touch support, and all that is bound together as a seat, and there's some operations you can do on them. And then there's a few other interfaces. These interfaces can be developed and versioned independently, so there's enough flexibility here to actually do new development and experiment with things without destabilizing the core. The best example of that maybe is the last here, XDG shell. It's an interface that's meant to encapsulate basically all the operations you need on a typical desktop top-level window, like you can maximize them, full screen, things like that. And that's a relatively late addition to this set of interfaces, and it took quite a few iterations to like figure out how we want it to look. But that did not affect the other interfaces at all. They could remain stable. And it's also kind of optional. Like Wayland is often used in non-desktop context, for instance in car entertainment systems, IVI. They often use Western, but their compositors will not implement XDG shell because you really don't want to maximize your speedometer or something like that. So that's not something that's relevant there. So they have their own little interface that's suitable to their needs. In many ways, this is, I guess, a bit similar to X extensions, and thus it's not really revolutionary. Yeah, moving on. So why would we want to embark on calling from X, which has served us well for like 30 years or so, to something new, where we have to like basically redo a lot of existing things in new ways? I try to come up with a few reasons here and put them on the slide. One reason is that, at least the X people will tell you that there's a lot of craft that has accumulated in X over the years, and I tried to mention a few cases earlier where it's actually the case that the core X protocol is largely unused because it has rendering and it has fonts. Nobody uses those. And so that's all craft, and we have to carry it along as long as we're using X. Doing a fresh start with a new protocol allows you to simplify things. Another case where that is relevant is I mentioned earlier that putting the compositor and the display manager into the same process, basically with one slew lets you drop all the window manager specific protocol parts, like the parts where the window manager can request that it gets map requests sent to himself before they are made effective, things like that. And yeah, so that's on the protocol side. What I mentioned a bit earlier is that sandboxing is a real possibility with Wayland, whereas it's kind of hard to do with X. And Wayland will hopefully help us in making that actually something that's really secure, so we can allow people to run applications that they don't trust, and we can be fairly certain that they don't steal your credit card from some entry in another application. There's also some possible efficiency gains here. I put the last point on there. In theory, it's possible to like implement something close to zero copy for buffer contents with Wayland, where you can have the clients basically allocate their buffers in kernel memory and then just pass them on to the compositor, and the compositor passes it on to the graphics hardware. Most current compositors don't do that thing, but at least in theory, it's possible. Kind of interesting. So, yeah, not sure how convincing you find these reasons, but that's what fit onto one slide. Of course, there's also some concerns or downsides here, so maybe reasons why you would consider staying with X rather. The first one, as I said, in Wayland, the display server and the compositor are just the same process. So if your GNOME shell crashes, that means all your applications lose their connection to the socket connection to the compositor gets closed, and then they go away, and your session essentially dies. Which looks dire in the first place, and it's actually a problem if you're doing development on the compositor, if you're doing GNOME shell development, like partially your own, and this is something that affects you probably every day or every other day. But I think maybe it's not that big of a concern for regular users. If you compare this to what happens under X, if your window manager crashes, all your windows lose their decorations and you cannot move focus around anymore. So I guess a normal user would be pretty quick to head to the power button and power cycle the system at that point. Anyway, so in reality it might not be that big of a deal, but it's a concern. And of course we always strive to keep our compositor from crashing anyway. Another concern is interoperability. I talked a bit about the fact that the Wayland protocol is comprised of these separate interfaces, and different compositors may actually just implement a subset of them, like they may just not implement the XDG shell interface, and then maybe a GNOME application will not run under some other Wayland desktop, like Hawaii, I believe is the name of one. I think this is something that will sort itself out over time. The XDG shell interface is really settling down now, so there was some very active development on that, but now it's fairly stable, and so I expect that we'll reach stability here where most of the important Wayland compositors implement the same interfaces with the same version, so we can actually ensure that applications will generally run. But it's a concern to keep in mind, and it's different from X, where really everybody's using the same X server, and then they run a different window manager maybe, but the X server at least always speaks the same X protocol. Yeah. Last point is driver support. So currently the NVIDIA driver does not support Wayland, and we're talking to them about having them add suitable APIs that we can use to implement Wayland on top of the proprietary driver. Right now that's not in place, but Nouveau works fine. So this is something that I expect will fix itself over time. Right, so moving on, I have a brief section here about history. I'll try to keep that short. This is really prehistory, this slide. I'm not sure how many of you can think back to the early 90s, but there was actually attempts to replace X or do something better than X early on. Fresco was a project that the X consortium did, in the early 90s, 93 or so. And later on, when the X consortium ceased to exist, it was renamed first to Berlin and then to Warsaw, I believe. Not sure that's still around, but there was an attempt to do a better interface, and in some ways it's a precursor, I think, to what Wayland is doing now. GGI, the General Graphics Interface, also a project that was started in the early 90s. There was an attempt to get graphics support into the Linux kernel. That was probably too early before its time. It didn't have much success. The project is still around. I believe it's focusing on other kernels now, other than Linux. And then there's some others like DirectFB, which was an attempt to get some frame buffer device into the kernel that supports better graphics. And all of these had some level of success in their time, but none of them came close to replacing X or be a successor to X in the way that I think Wayland is nowadays. And switching from prehistory to more modern history. So the story of Wayland really begins, I think, in 2008, when kernel mode setting was introduced. I said earlier the GGI project was an attempt to get graphics into the kernel, and in 2008 we tried that again and realized that what you really need in the kernel is mainly the mode setting part of the X drivers, and that's what we nowadays call KMS. I actually looked back, there was a Fedora 10 feature called kernel mode setting back when this work was started. The original motivation for this was, I believe, largely driven by having a better boot experience. We wanted to minimize the number of mode switches between your bootloader and your desktop. Plumis was also started around that time as a component of that whole better boot work. And yeah, in the same year, Wayland was started by Christian while he was still at Red Hat. I vaguely remember seeing like the famous rotating flowers demo over his cube wall back in 2008 or 2009. I also remember discussing client-side decorations with him back in those early days, and I was not convinced at all at that time. So sometimes these things need some time, and I think now that's the right thing to do, but back then I was not convinced. Well, didn't want to move on. Moving down this slide, GTK got an initial Wayland backend in 2010, and things continued to move at a fairly slow pace. And around the end of 2012, when Christian declared Wayland to be 1.0, that's when things really started picking up, and we decided that we had to look at porting GNOME to Wayland in early 2013. I remember we had a preparation meeting in Christian's kitchen when he was still living in Cambridge. That was in March 2013, where I had to pick up Jasper and drive out to Cambridge, which is normally like a 30-minute ride from where I live, but it took us more than 2 hours because it was a terrible snow day. But it was very productive, and in the fall of 2013 we released GNOME 3.10 with what we call experimental Wayland support. And then another cycle on this spring we released 3.12, which has a lot more complete support, and it also starts using the XDG shell interface now. And basically that's where we are now. We're in the middle of yet another cycle, and what we're aiming for in Fedora 21 is to have basically the Wayland session be day-to-day usable. There will still be some gaps. I'll talk about that in a bit. I'll switch back one more to a little more technical details. I wanted to explain briefly how the Wayland port of GNOME actually looks, what the involved components are here, and what we've done. So I mentioned on that history slide, GTK has a Wayland backend, and GNOME Shell or Matter are our Wayland compositor. For input, it is using libinput, which is shared with Western and other Wayland compositors. Essentially, a new library that tries to extract a lot of the low-level input handling functionality out of X drivers and make it available, so Wayland compositors can use it. If you want to know more about that, you probably want to go to Hans's talk after lunch, where he talks in depth about input in Wayland. And a lot of functionality that used to sit in GNOME settings daemon. I'm not sure how familiar you are with the internals of how a GNOME session looks, but there's the compositor window manager, GNOME Shell, that's running as the one big process, and then there's GNOME settings daemon, which is a daemon process without user interface, which handles a lot of settings changes and applies settings to your X display and so on. And a lot of that functionality that used to be in GNOME settings daemon is now moving directly into GNOME Shell. Examples of that are display configuration, keyboard configuration, color calibration. All that works now. Basically, GNOME Shell directly reads the settings and applies them. Wouldn't really make much sense to have another detour through another process for that. And in some cases, GNOME Shell actually exposes dbus APIs where for instance, the control center can get information about your displays, so it can present them in the display panel. That's a new dbus interface that we added. And then there's another dbus interface for taking screenshots and screencasts, which I mentioned earlier as an example of like a privileged client that needs a special interface. In this case, we chose to use a dbus interface. Mainly, I guess, because we already had that interface before we started porting to Wayland. And looking a bit at the current status of how mature all this is. As I said, down at the bottom of the slide, our end goal is to have the Wayland session be day-to-day usable in Fedora 21, which I guess you can parse that either way, but day-to-day usable does not necessarily mean that that'll be fully complete, so there's going to be a few gaps that I list above there. On the GTK side, I mean, the backend itself is really stable. I haven't seen any crashes on applications just because they're running under Wayland. But drag and drop is currently not supported. That's largely because the internal API that GTK has for drag and drop does not really match the Wayland API very well, and it's kind of involved in moving things around to make it work somehow. That'll take a little more time. And in the on the control center side, input configuration, I think we will not have that working in F21. But input itself is working pretty well. Lib input has made great strides recently. Like one of the early problems when you were logging into Wayland, like for the last year or so, was that you didn't have input acceleration. So if you move your mouse, you kind of feel that you have to push really hard, and it moves very slow, which is a very obvious thing that kind of after 5 minutes you give up and go back to X where the mouse actually moves. And so that's in place now. Lib input provides input acceleration. We cannot configure it yet, but that will come. And another thing I believe that recently landed in lib input is palm detection. So if you, like me, tend to have your thumbs on the touchpad, that should work a lot better now. Yeah. Wacom support, I talked to Hans about this over breakfast this morning, is actively being worked on and will appear in lib input, I believe, probably not in time for F21, but soon thereafter. And yeah, that's the current status. And first you can ask, why does all this take so long? I kind of outlined that we started the porting early 2013 and now it's mid 2014, so we take our dear time in getting there. And I guess some reasons for that is that we kind of have a well-working and polished desktop on the X now with Chrome 312, and we don't really want to risk that or give people a bad experience, because the right way to think about the Wayland port is that if we do our job really well at the end of it, then users will not actually notice that they're using Wayland and not X anymore. There will be no obvious signs. So, and if you do this kind of invisible change, it would be a little rough to like take on board big regressions because we want to get there early. And rather we want to avoid regressions and take our time and not make this the default before the port is actually complete. Yeah, another reason is features. While we're doing this Wayland porting work, actually, we're working on features at the same time, like a lot of things like the high DPI support, better touch support, pervasive animations, all that is being developed in parallel to this work, so that of course slows things down. Yeah. And X had 30 years to establish itself as our de facto standard display server, which in itself does not necessarily mean that much, but a lot of, for instance, the GTK APIs are more or less directly modeled along X, which means it's a little harder to make them work on the Wayland sometimes, and we may want to replace them with APIs that are more neutral or maybe modeled along Wayland concepts, and that again takes more time. The last point is that we actually want to keep the X code paths working until we're ready to switch over to Wayland as the default, and maybe not even then. Which is always a little harder if you have to like keep two code paths working in sync. And just guys very often ask, like, can we not just drop all this X code and start over from scratch essentially? Which would have gotten us to like a Wayland desktop, I guess, a lot quicker, but the road would have been a lot rougher. So we chose not to do that, and we'll keep the X code working, but that means that we have to like do a lot more internal refactoring inside Mutter to make things work nicely in parallel. And that's it. That's my update on Wayland. If you have any questions, now would be a good time.
Are you thinking about introducing some signals when, for example, in Anaconda, we have a problem that we start the X server and then the window manager, but we have no idea when it is actually initialized and when we can start like GUI stuff.
Okay.
So that is a big problem that I think Wayland could solve quite easily.
Right. So I think that problem will not exist under Wayland per se, because in Wayland, the compositor itself is the desktop shell. So as soon as you have a connection to your compositor, you can basically assume that the desktop is operational and you're good to go. You can actually, we do have a signal under X, actually, if you want to know about it. There's a window manager change signal somewhere inside GDK that you can listen for. That's on GDK screen, I believe. I think you should get that in that situation, so that might be a way to go.
Well, you cannot initialize GDK with the X server and is not initialized.
Right, yeah, it might not be easy.
We need to know when we can initialize GDK and GDK.
Right. Yeah, you have to look at that in detail, I guess. But in principle, there's a signal already.
I would like to ask what are the current plans for network transparency, or at least like screen scraping support or something in the toolkits?
That's a good question. I think there's like Western has a concept of backends, and there's an RDP backend, for instance, for Western. I think something like that would be possible in GNOME Shell as well. So that's, I guess, the level of thinking that we currently have. And you can, of course, always use some dedicated separate protocol for that. Okay. Okay.
Hi. I just had an easy question. Is suspend known to be an issue with Western right now, or would that Wayland, or would that just be a bug on my system?
It's not known to me.
Okay.
Probably just a bug.
Probably just a bug.
Yeah. All right. There's no further questions. Once again, there's one more.
So the media, at least, has made a big deal about the Wayland versus Mir divergence. Has there been any effort whatsoever to bring them back into the fold, considering that just about everybody else has gone Wayland? Has there been any effort to try and pull those developers back in, take some of their better ideas and actually make Wayland better?
I haven't done any backroom deals or any things of that sort. I don't know what they're going to do with Mir long term. We'll have to just wait and see. There is a GTK backend for Mir that they have pushed in a branch. I asked them at Guarec if they were interested in merging that. Maybe next cycle. So I don't know. We'll have to see. Wait and see what happens there. At the end of the day, the Mir backend is very similar to the Wayland backend. It's basically the same code. So it doesn't seem worth having two entirely separate systems there. But we don't control that. All right.
Just a simple question. Does GNOME Wayland work with KVM?
I think KVM can. Sorry, KVM. Yeah, it does. Yeah, actually, if you go into, we have this continuous build system, integration system called build.gnome.org. If you go there, we show you what we call smoke tests, which is basically we build the latest tip of master everything, and then we compose a VM out of it, and we launch that, and we take a screenshot of the login screen to verify that things work. And we do that not just for like GNOME under X, but also for classic mode and for GNOME under Wayland. And until recently, it worked. It broke over the weekend. I have to track down what's going on there, but it works. Yeah. That was waiting for a long time for landing some NISA patches that were needed for that, but also in master now. All right. Thanks everybody. Any questions?